I'm that guy which nobody can pronounce his name, so people call me MJ. At the moment, I'm with Red Hat. So today, we'll talk to you about OpenShift Enterprise for enterprise container developers. Basically, how OpenShift enables developers working in the hard conditions in enterprises in a highly regulated environments to develop containers in an agile and fast way. And sorry for all my hicks on the presentation. It's the first time in UK when I'm doing meetup talk, so it will be a few of those. About me, I started my career in 2004 as a sysadmin, still at school. Most of the time I worked at a big corporation, so I know the hard stuff. And you come in fresh to the big bank, big organization. You want to change the world, and we give you Windows XP with saying like, do something. And Notepad++ in the best case to develop something. So I'm with platform as a service products basically for almost all my career now. So same with containers as we know them now. Yeah. And today I will cover a little bit OpenShift versus Kubernetes because this is almost one of the most common questions which I'm getting from clients, from friends and colleagues. What's the difference? What the Red Hat is doing basically to make it different? Another one, why development experience in highly controlled environments is difficult and is important. And I will try to do short demo, if demo gods will be good today with me. Till this point we weren't, so I have a recording as a plan B. So we'll see. So OpenShift versus Kubernetes / do-it-yourself. So if we look to diagram, Kubernetes would represent a blue part, maybe a little bit more to this side because many contributors are contributing more and more to Kubernetes core and extending that. Everything was green would be OpenShift, meaning it's a kind of one of the myths that it's the same thing. OpenShift gives you all additional features which construct a platform as a service solution. Being Kubernetes is your operating system for your data center, but to have full-fledged platform as a service solution, you will still need logging, you will still need storage, network isolation, some kind of artifact repository, registry. You still need to build your images somehow, because those who knows Kubernetes, it knows that Kubernetes out of the box does not build images. You just give it and it runs. How to build the image, how to make sure that build is standardized, how to make sure that your developer does not use some kind of random image from Docker.io with vulnerabilities or Maven, which is 15 years old. You have to, when you're running at scale, and at scale it's not 100 servers, it's thousands, it's millions containers, you need to make sure you are in control of your ecosystem and your environment. And OpenShift with all the green stuff can help you to do all these things. And the most important feature about that is that each and every of those blocks are swappable. So if you already have your own built platform, just take it out from here and plug in yourself. If you have your own network provider, which is compatible with Kubernetes, take the one which is in default in the product and swap for your own. And some numbers, somebody did few white papers calculating that cost of running do-it-yourself solution, something like Kubernetes plus everything on top is about 7 million a year. I know it's a little bit blown up number, marketing people do that, but it's still big. If it would be 1 million, it still would be big. So, development experience in highly controlled environments. I could tell you like 100 stories about stuff, how people are doing things. So usually big enterprise wants to go to cloud journey, build microservices, everything in the containers. And half of the developers running Windows 8. So how to build something on Windows when you're not allowed to run virtualization, when you're not allowed to run, example, Docker. The thing about kind of still interesting about Docker is we build everything based on socket. So to run on Windows, you kind of need to run some VM. And most of the guys like who worked in a big company who can't run Docker on your own laptop at work? Lucky you. I can see few, but you wouldn't imagine how many people can't. So, example, what happens after that? People getting some kind of random build servers from somewhere running under the table, basically, or in OpenStack environment or somewhere, building stuff there. Basically, dev servers. And it's in control, which basically what kind of image is being used as a base layers, what kind of libraries, who owns the data, libraries, like who can access your containers. So if you have a team which works with payments, heavy payment basic application, and produces some kind of images, and you have another team which works with HR front-end application, which does not have any data regulation almost. You want those to segregate those, and you don't want to apply same rules to both of them, because one have to comply with all PCI DSS stuff, another just have to write some web application. Usually in the big companies, one fits all. So, and the last one, when basically next big vulnerability appears, what part of your infrastructure is impacted? What you need to rebuild and how? It's not 100 VMs, it's like 500,000 containers running in tandem within the embedded with different applications. And now you need to rebuild all of them with JVM plus 1+6. How? So this is the problems basically a lot of people trying to solve. And I will now try to show how you can use OpenShift as your development tool itself. So basically you develop containers, use the same platform itself, and at the same time, operators, platform owners can track everything what you do, basically can control what you use and how you behave. So let's see how it goes. Because the last thing you want is developers like this in your organization. And you submit something to CI/CD pipeline and waiting like 30 minutes, 40 minutes until it builds somewhere. Okay, so we will try to build few containers, run it, and show how you can debug basically when you run it. It's very simple application. It's just front end, which hits API. API hits internet, gets random picture from the internet and returns to front end. Difference is not each and every request which hits front end is being sent to API, kind of microservice architecture. So you can scale those separately. If you have big traffic, you can have 100 of front ends and 2 back ends. Okay. I'm not sure how it goes with the microphone now. I'll try to show UI and basically CLI too. So we have simple file structure, 2 Folgers API front end and some libraries, external ones. Basically, it's a simple Go by application. So first of all, we build binaries. In this case, I don't build binaries in this case, Go. It could be Java, Python, everything somewhere outside. I build on my workstation because I'm developing there. So we build those things. Now we want to containerize our application and deploy to platform to see how it behaves in tandem. So I have some stuff prepared for myself. So spoiler alert, everything what I'm doing here is pure OpenShift. We use Kubernetes features, but all the commands and everything is what OpenShift gives you additional to enable development experience. So we create a build. So we create build for API, and we create build for front end. What it does for people who don't know OpenShift and know something like Jenkins, it's just something like empty job creation. So what we created 2 kind of virtual artifacts, something as empty Jenkins job. It does not do anything until you provide instructions. Okay, I will try to do that somehow. So we created 2 empty shells for our build, but we don't do anything. So now we want to execute a build. So what we do, we first of all build our API. Cool, thank you. So what we're doing now, we're executing a build. Okay, that was fast. So what it did, we executed a build. It uploaded all our local file system to the OpenShift and executed build remotely. This means we did something similar as you would do Docker build, but we did that remotely. So everything is being logged, everything is being followed, and libraries are being controlled. So we do same for front end, and we'll try to check it in the UI. So we can see that stuff is happening. Oops. So we built image, we published in the internal registry as a, imagine it's like a cache. Okay, so we have 2 images built. Now we want to run it to check how we work together. So make hint. So we initiate new application saying, I want to deploy this application API, and I provide some environment variables. So it should be basically 12-factor app, so everything is configurable. Now we do same for API. So what happens? The image which I built previously, I just told OpenShift to run it, and it got spinned from the things we built before. So let's try to access it. So for accessing, we expose it application to the web traffic, something we enable, configure internal HE proxy or any other load balancer of your preference to enable web traffic to the container. Okay, so let's open our app. So if I hit any of those, I'm hitting local front end and it's not being sent to the backend. If I'm hitting random, I should get a random image from the internet. If I refresh it, I'm getting a new one.
Very risky.
A new one. It's very risky. I expected cats. Okay, so we have stuff running. Our marketing happy. Our clients are happy. So somebody came and said, I don't like the name images in the application. Can you change it to something else? I said, like, why? Yeah, why not? I just go in, modify the application, and I will say that it's not images. So now what I need to do, I will need just to execute build again. So what happens? I can see that build is being initiated. So because now we changed the code, Docker, same as with Docker build, you're rebuilding top layers, so everything downstream is being rebuilt. So you can see our application is being rebuilt and is being published. And at the same time, the things which we created previously, deployment, we don't need to create those again. It happens automatically. Basically, we have rolling update, throwing stuff out. Still works, not images. Okay, some operation guys came in and said, guys, we need to enable higher logging level on the API because we don't know what's happening there. Can you set environment variable? And this environment variable by time bomb is time bomb equals true. Yeah, and because our operators does not think about what we do, we just set it. Time bomb, yeah.
Yes.
So we set it and see what's happening. So we hit new redeployment, containers being reestablished in new environment, and holy moly, something is happening. Our container is getting raw, basically. Application, let's try to hit random, nothing. So at this point in time, we need to investigate what's happening. So now imagine this application being something 10, 20 containers running together, memcache, few proxies, few backends. To debug something running in this complex environment, you need to run everything in the same environment. Because if you run one proxy, maybe it behaves okay. But as soon as you start running with everything around it, it starts breaking up. So we have this. Now we're going to CLI. We're checking what's running, first of all. And we see this pod is being on error stage. So I say OC debug this container. But at the same time, one sec. So at this time, what's happening? OpenShift spin me a new debug container of replica of what I have already. And it makes sure that container does not die, does not restart. So it keeps the certain state for me to allow to debug. At the same time, some big stakeholders calls and says like, guys, we don't serve in traffic. We need rollback. So what we do, at the same time, we do deployment config API. We do rollback of our existing application.
That was PAI, not API.
So what's happening? OpenShift basically goes, takes the previous deployment and throws it in, but we still have our debug container running. So we can go in, we have prompt. But okay, some people more like UI, so we can do that via UI. So we can check what's happening. We execute command. We can see time bomb. We can grab environments. Basically anything what you can do in the cluster, in the usual container. So time bomb, right?
Yeah, that's right.
So we unset it. Bin API. We run it again. Everything works fine. We know where the problem. We just do exit. And OpenShift will destroy the debug container. So we can hit it again, rebuild, change application, and throw everything again to the production. And it will do the redeployment again of new application. And everything what we did here was API calls to OpenShift. We didn't run any container runtime on our, on our workstation. You can do that from any kind of server, Linux, Windows, anything. So this basically enables to develop containers in a fast way in almost any environment. Each and every action I did, it was logged. Each and every base image which I used was controlled by platforms operators, and each and every project can have a different right. So if I'm working on different project, I can have everything allowed. But if I'm working with payments, I have strict rules what I can do, what kind of libraries I can use, and so on and so on.